A final topic in this finance module that I want to explore a little bit further is how an amortization schedule is made. Now, we had looked at this a little bit earlier. I showed you a website with a schedule, but I want to talk about how it's actually made. Now, an amortization schedule, as a reminder, is going to be a table that breaks down the payment number, how much of that payment goes toward paying off interest, how much of that payment goes toward paying off the principal, and what the current balance is on the loan. We're going to work through an amortization schedule for a $1,000 loan at 12% APR, assuming that you're making monthly payments that you're going to pay off in 6 months. So I'm actually going to work through this schedule for all 6 months so you can kind of see how your payments go toward paying off your loan completely. Now for this scenario, if maybe we take a look over here, this is the actual amortization schedule. So it's going to be a table. Sometimes what's left off in the table is the payment, but I'm going to include this column in here so you can see that the payment is fixed for the life of the loan. This is going to be a fixed installment loan. So you're going to send in a fixed payment every month. For that payment, part of it goes toward paying down the interest, and then the rest goes toward paying down the loan balance or the principal that's paid off, which then ultimately reduces the loan balance. So we're going to talk about where every one of the numbers comes from in this table. Alright, so let's go back up here and take a look at this work. So this is going to be the process to build the amortization schedule. So the first off, for a loan, you have to determine the payment amount, and that's going to be using this amortization formula. Once you know what the payment amount is going to be, for a particular payment period, we're going to find the interest paid by using I equals PRT. Then the principal paid is going to be what the payment is minus the interest. And then the new balance would be whatever the previous loan balance is minus the principal that's paid off. And you're just going to repeat this process for each of the payment periods. So first, for this loan, let's determine the payment amount. So I have a $1,000 loan at a 12% APR. We're going to assume a monthly payment, so my value for N is going to be 12. And then the time for this loan is going to be half a year. Okay, so remember that you have to have units match up between your rate and then your time. Alright, so here is our amortization formula. So I put 1,000 in for the loan amount. My rate is 0.12 divided by 12. That's repeated here, and that's raised to the exponent of n times t, so 12 times 0.05. This exponent up here gives you 6. And then that should seem reasonable because this exponent also indicates for installment loans how many payments are made to pay off the loan. So since I have 6 months to pay off the loan, I'm going to be making 6 payments total. And then down here I have this repeated and then minus 1. So then right here I have the calculator screenshot, so I'm not going to go through entering this in my calculator, but I took this value and I stored it in A. I then took this numerator and I stored it in B. And then I took this denominator and I stored it in C. And then this is the final entry then. So we get that the payment for every month is going to be $172.55, rounding to the nearest penny. Okay, so now that we know the payment amount, we can actually come to the amortization schedule. And we can fill that in for the payment for every one of these payments that are going to go through. So to start this schedule, so notice right here, okay, so before even the first payment goes through, this is the starting loan amount. I'm going to be making 6 payments to pay off my loan, so I filled in those payment numbers. And then the payment is fixed for the life of the loan. Alright, so let's talk about where these other numbers are coming from. Alright, so we'll come back up here. Okay, so I'm on my first payment that's going to go through. Okay, so the amount of interest that's going to be owed for that first payment. Okay, so if using this formula, my principal is $1,000, my rate is 0.12, and then the time is over 1 month. Which is 1/12 of a year. So then that gives my interest due is going to be $10. So I'm going to send it a payment for $172.55. the loan company is going to siphon off $10 for themselves, which means then $162.55 goes toward actually paying down my loan. At that point in time, after payment 1 goes through, my loan was at $1,000. I will have paid off $162.55. Now my current loan balance is $837.45, which will complete the first row of the table. So if you go back to the table, notice that this is what I have for my interest, that's what I have for my principal paid, and that is what I have for my current loan balance. So let's go into actually this payment for the second month. Alright, now at that point in time, now the interest, I'm still using I equals PRT. At this point in time, the principal of the loan is $837.45. The rate is still 12%, and the time is still going to be over 1 month. So 1 month has elapsed since I have made a interest payment. So over that month, I will have owed in interest $8.37. You're going to send in your fixed payment of $172.55. They'll pull off $8.37 for interest for themselves. That leaves $164.18 to pay off the principal. So let's figure out what the current loan balance is then. So I had owed $837.45, but we just sent in a payment of $164.18. That means my current loan balance is $673.27. And then these numbers then complete the second row of the table. So if we take a look over here, there's the interest that's being paid off. That's how much then of the payment goes toward the principal, and then here's my current loan balance. Okay, so at this point in time, if you just look at what's going on for all of these other months, you're basically just repeating this process. Okay, so now there's my current loan balance, so we're going to figure out the interest. If that's how much I'm paying, that's how much they're going to pull for the interest. That's how much is going to go toward paying down my principal. We'll subtract that from that current loan balance, and then that gives me the loan balance after the third month. So as you're working through these calculations, I want you to notice a couple things in this table. Every time you send in a payment, because the loan is going down, then the interest is going down. As I'm paying less interest, notice more of my payment goes toward paying down the principal. So in one column the amounts are going down, and in the other column the amounts are going up. Now normally at this point in time then, after that last payment goes through, because remember I wanted to pay off my loan over 6 months, when that last payment goes through, this really should have an unpaid balance. It should end up at 0, but because of rounding error, that's why I'm off a little bit. So what would normally happen is on that last payment, they would just adjust what that you owed, so that way the unpaid balance just is at 0. So I wanted to show that the payment is fixed for the life of the loan, so I just left this here without to 55 cents, and so that's why I ended up being a little bit off just for that last row. Okay, so this is how you make a amortization schedule. And if you were to take out a car loan, like for instance for 60 months, then you would have 60 rows in here showing how every single payment goes toward paying down the loan balance and how much of the payment goes toward the interest. And then if you were to have this for a home payment, let's say you had like a 30-year mortgage, you could actually create one of these tables drilling out for every year how much interest is being paid over the course of that year, and then you could even look at month by month how much is actually going toward paying down the interest versus how much of your payment is going toward paying down the principal, and then what the current loan balance is at any point in time.